In this module, we're going to be discussing more about copper and mostly about installing uh, copper tubing and fittings. So the objective of this section was going to discuss and describe the hangers and fasteners used to support copper tubing, explain the insulation requirements for copper tubing, and explain methods of pressure testing copper tubing systems. And it will be a performance test. We're going to install some piping um, to be able to at least go through the process and going through how to size up, how to prepare the pipe, how to support it and install it inside of walls. First thing, all tubing must be installed and supported by both the tubing and its joints remaining leak-proof. It must not leak. The worst thing you can have is a water leak inside of a wall after the wall is finished. Because number one, trying to find where the leak is coming from. The other ones, because it's enclosed, to be able to get into it to make the repairs. To repair copper tubing, usually it's surrounded by flammable materials that can catch on fire. So we must, if you do it right the first time, you save yourself a lot of problems in the long run. So copper tube is supported in a variety of ways and with various sizes of hangers and supports. So every pipe size have its own special type of hanger to support it based on the size. Because number one, we don't want piping moving around in the wall. We want to support it correctly and sturdy, so it's not going to put tension on the pipe, which can cause it to be damaged from the weight. So supporting all types of piping is important. We just don't run the piping without supporting the pipe. And to go over something quickly is that the support goes in before we actually cut the first piece of pipe. We must know where we're going to run the pipe. We must know how we're going to support it and what type of supports we're going to be using. And so how you're running the pipe will determine what type of support you're going to be using. So when it comes to hangers and fasteners, hangers is something that's supported and suspended. That's a hanger. Fasteners are what could be attached to walls or floors or things like that. So again, the specifications for hangers and supports are determined by the following factors. First, the combined weight of the tubing fittings and valves. So in other words, if you are putting in a very large valve or heavy valve, the supports need to be closer. You need to be close to the fitting or close to the valve to make sure that we're not putting stress on the piping. Next, the maximum weight of the content that the tube is carrying. If it's water, if it's oil, or what is ever going through that piping, is it waste? Now, water is heavier than most people think. A gallon of water weighs over 8 pounds. Just 1 gallon, over 8 pounds. So if we know how much weight in that pipe, based on the length of the pipe and the size of the pipe, we can determine how much weight that pipe is holding. And so being able to support it. Materials such as wood, concrete, steel, the hangers will be attached to. So in other words, we are determining what type of hangers we're using based on where we're attaching it to. So if it's steel studs, we need to use a certain type of hanger. If it's hanging from floor joists or ceiling joists, we must be able to use a certain type of hanger or support. Now, here's the other thing, the distance from the anchor point to the tube. And so again, how far is it hanging? Is it going to be hanging from a beam clamp that may be 20 feet up in the air? Or if it's just an 8-foot ceiling? So The potential for corrosion between the hangers and the tubes, fittings, and valves. So if it's in an exposed area and things like that, we need to that exposed to an environment that can cause harm to the pipe, we must consider how we're going to install that pipe, because it might need to have some type of coating or insulation or something around the pipe. Or matter of fact, depending on the environment, if it's a high humidity and running cold piping, the pipes need to be insulated to protect it from condensation, that water is not dripping from the piping, from sweat, from the condensation. The potential of corrosion between the hangers and the tubing, fittings, and valves, the expansion and contraction of the tubing. Now, here's the thing: if you're running hot water through the pipe, which if it's a supply pipe, you're going to have hot water to sinks, and based on the distance, that heat will rise to cause the pipe to expand. And that expansion will cause movement in that wall of the piping. And so you need to have space for it to expand. Matter of fact, very long runs, because of expansion and contraction, we need to have be able to have expansion joints to be able to allow the pipe to expand without damaging the piping itself. So again, expansion and contraction of the tubing must be considered when you're hanging the pipe. And vibration of the equipment attached to the piping, to the system, must be considered too. So he's connecting to a piece of equipment that that requires water or whatever flow through it. We must be able to consider that. For example, for refrigeration systems that have a compressor, we actually put extra bends in the piping to be able to allow that compressor to move freely without being hindered by the piping itself. So we're not putting stress on the tubing that can crack or break based on the vibration. How do we attach it? Number one, these are different types of clamps. The C clamps, it doesn't support the pipe itself in the tubing, but it supports the hanger that is supporting the tubing. So again, these are what we call beam clamps or C clamps, and these are used to either attach a threaded rod to it or a bolt and nut to be able to hang some type of support from it. Now, the support on the right side is a one-hole strap. That's one-hole strap is designed to hold the pipe against a wall or some type of structure, or it could be a stud. So in other words, it will support the pipe by using just one screw to go through the strap, and that strap will hold the pipe in place against a surface. So tube attached to a part of the hanger that touches or connect directly to the tube. It may be designed for either heavy duty or light duty for covered insulated tubing or plain tubing. So again, there's many ways to attach it, but this diagram you see here shows a couple different ways to do it. Again, like the C clamps, it doesn't hold the pipe directly. It does not. It will hold some type of hanger that will support the pipe, and that one hold will support the pipe directly. These are we call on the left side clevis hangers. We use this for larger pipes. Matter of fact, they make it even for smaller pipes, so it's not just large pipe. And usually at the top of it, let me see if I can do a laser. This is where your threaded rod will go, and that threaded rod will be connected to one of those C clamps. We call beam clamps. So in other words, that rod could be 10 feet long and hanging from a beam, and this what holds the pipe. So the pipe will be inside of this space here, and it's movable. So it's not holding the pipe solidly. It's not secured. In other words, the pipe can actually move back and forth a very small amounts if there's expansion or contraction. So we use this again when we hang a pipe above the ceiling, above your head, and it's just used for that purpose. And this is a very common type of clamp. Again, if the pipe's insulated, we just use a larger clamp that will fit around the installation of a pipe. And again, it is not physically holding the pipe stationary, and that the pipe can move back and forth slightly for, again, if there's any type of vibration or expansion or contraction of the piping. Slip rings is very simple. It goes completely around the pipe, and it will support the pipe. So hangers are used for horizontal or vertical support of tubes. These are other types of hangers you would find. I showed you the one hole in that other slide, but this works very similar. This is like a plastic support that is designed to be nailed to a wood stud, and you slide the tubing through it. Once you nail it down, it will hold that pipe in place. This type is a two-piece. It actually slides open so you can go around the pipe, then you can slide it down, then you drive the nail into the wood, and that nail will hold that clamp in the closed position. This is a two-hole strap. Two-hole. It takes two screws or two nails to attach it compared to one. The one is, of course, faster. There's a pipe strap. This is a perforated strap, and this perforated strap has multiple holes in it, so you can cut it down to whatever size you need it to hang a pipe. So you can actually nail it into a stud, or you can nail it into, matter of fact, you can hang it from a ceiling joist. Put a nail in it to hold it in place, and then go around the pipe and put a screw around the pipe through the perforated holes to hold the pipe in place. So tubes can be supported on a wood frame construction with several types of tube attachments. And so these are for PVC or plastic pipe. This is for either black pipe, copper pipe. This is definitely copper. It's copper coated for a reason. So it doesn't have that electrolysis that can affect the pipe. Same thing with this strap here. We use it on copper pipe. This is another type. This one got insulation around it, so it keep it from metal against metal rubbing if there's movement. And this, basically, you just nail this into to a floor joist, the ceiling joists that hung above the ceiling. These are designed to get nailed into joists also to hang down. So this is the type of hanger that's used with unistrut. Unistrut is a channel that comes in either 10-foot lengths or sometimes longer, like 20-foot lengths, and we cut it down to size to be able to fit what we need. So that hanger, which can be used as a trapeze, or it can be mounted to a wall to support piping. And you find these in commercial applications and industrial applications more than you find in residential. Number one, the cost of it is certainly more than you need to spend. And this type you see here has a vibration isolation gasket supporting it away from the metal clamp that holds the pipe. So this used in quite a bit in refrigeration and air conditioning type of work, because there's vibrations in the pipe from the mechanical systems operating. So but if there's any type of movement of piping, this will be extremely helpful because it will isolate the tubing. Again, this can be used mostly in commercial and industrial type of piping arrangements. Now this is another type of clamp you find. This is a vertical hanger, and basically it straps around a pipe. And it's usually used when the pipe is vertical, going up and down. And it will support the weight of that pipe instead of forcing the weight at the very bottom, which can cause a lot of stress and can damage a pipe or crack the pipe. So this will clamp around the pipe and hold it, and you can use support to be able to of these ears on the side of it to be able to hold that pipe in place. So again, you size these type of straps based on the pipe's size, and so they make a different clamp for every size, and it will use bolts and nuts here and here, and once you close it up all the way, it will hold that pipe tightly. And so it doesn't matter how large that pipe is or heavy that pipe is, it will be supported around using that clamp to support the weight, not the weight on that fitting at the very bottom. So vertical hangers are also called tube riser clamps. Consist of a friction clamp that can be attached to structural site components to support the vertical load. The load is the weight of the tube. Okay, again, there will be some type of support underneath one of these ears. Here's other ones. This is definitely found in refrigeration systems, and it's a special type of clamp. It looks very similar to a clamp that you will use on a let's say a unistrut system, only different. This doesn't have those clips on the bottom to support it. So other tubing attachment includes universal tube clamps and standard clamps, but it has these channels and things that we use. That's the unistrut I was explaining, which will support the piping. Here's another one. This is like a clevis hanger that going around copper pipe. So this is copper clad, it's covered with copper, so it's don't have that electrolysis. So this is definitely from a refrigeration system. For example, a supermarket refrigeration where they have what we call a rack system, and all the piping, multiple pieces of pipe will be tubing, sets of tubings will be coming out of this system like this. Connectors. The connector section of the hanger is the part that links the tubing attachment to the structural attachment. Okay, again, we're talking about the unistrut. I'm going to see if I can send a video about unistrut and how to use it, because again, that's a common thing you will find in commercial applications. So I'll just go through the steps real quick, and hopefully the video will show you more about it. So the connector section of the hanger is the part that links to the tube attachments and the structural attachment. The structural will be the strut. Connectors can be divided into two groups: rods and bolts, and other rod attachments. We're talking about the threaded rod. The rod attachment includes eye sockets, extension pieces, rod couplings, reducing rod couplings, hanger adjustments, turnbuckles, clevises, and eye rods. All of these are different things for threaded rod connections that you use to be able to connect all these things together. There's many different parts. So the video I will show you about unistrut maybe can show you all the different configurations of components that you can use. A clevis is an iron bent into, it's a strap basically. When it's an iron, you're talking about a steel strap. It's a clevis is a iron bent into the form of a U with holes in the ends to receive a bolt or pin. The reduce the risk of corrosion, use hangers and supports that is made from the same materials. So again, like I say, using copper, usually be a copper coated um, hanger or strap. Steel to steel is the same. Can you use copper and steel? Um, you should use always the same material or something that's designed for that material. If you are joining pipe and fittings of different metals, for example, copper and galvanized steel, use a dielectric union to prevent the corrosion that will occur on the pipe. Here's different types of clamps that you can use. For example, these are concrete anchors. Here's toggle bolts. And toggle bolts, here it is. Here is the head of it. Basically, we buy these and we add the length of screw that we need. And usually the screw is long. It's long for a reason, because when you fold this up, this have to penetrate the drywall. This, like I said, I call it a butterfly. You can fold it up so it's flat against the bolt. Then you have to slide it through the wall. And once this leaves completely into the wall, the cavity of the wall, it will pop open. It's spring loaded, and then you can tighten the screw up. So that bolt must be a lot longer than you need it. Other things, these are other types of toggle bolts, plastic one. This is a lead shot. It's a drop in that you actually drop this into the drilled hole. You drill the holes exactly the size that you need, and then you basically hammer this nail and it will expand and it will hold it down into concrete. It works very well. Usually we use it on concrete floors. To add unit strut. These are other types. This is designed to go into like wood, and it has a hex head that you can put a drill and drill this into the wood and to support it. Or they make somewhat anchors for concrete. And in this case, if it's concrete, you would they will have a special lead drop-in shot that you can use, that hang it from a ceiling. Here's other ones that you can find for beam clamps to support hanging from beams, I-beams, and sometimes angle iron. So this is a list and a little chart that goes into the structural attachments and the type of way to install it and the purpose of it and the application to use it for. So study this chart. It's in your book. Go through it so you get a good idea of the processes of different types of supports. Now, one thing that we have to do in copper, especially when we've got things at different temperatures, to insulate the tubing. And if something very warm or something very cold, it should be insulated. If you need something warm, they insulate the pipes to maintain the temperature in the pipe, so when it gets to where it's going, it's still holding its temperature. Same thing with something very cold. However, with something cold, it can freeze up or it can sweat, and that can cause problems because it can drip and cause floor damage or ceiling damage. And so we will insulate the piping for two reasons: for cold, to keep it from condensating and losing heat, and gaining heat rather, not losing heat. But when the pipes is cold, you would actually absorb heat. And of course, when it gets to the finished end, it'd be warmer than you want it. But something very warm, it would lose heat, and so the insulation would allow it to maintain its temperature. Safety focus. Here's a warning. You may encounter asbestos in old buildings, and yes, you will, especially during renovation work. If you encounter asbestos, do not handle it or attempt to remove it. Tell your supervisor about the presence of this material immediately. Asbestos is linked to long-term illnesses and lung diseases. Only trained personnel who have the proper equipment for handling and disposing of asbestos can deal with such situations. So in other words, you'll call a company out to be able to handle that. If you haven't been trained in it, don't deal with it because it's not safe for long-term health. Now, the next thing, once you install the piping, you did all the soldering, the pipes are supported. Before you put it into use, you must test it to make sure there's no leaks. And typically, we can use either air or you can use nitrogen to pressurize the system. We never ever, listen to me, never ever use oxygen in a pipe to check for leaks. Uh, Number one, oxygen is accelerant. It can cause anything that is burning to burn more rapidly, violently. So again, matter of fact, breathing pure oxygen is even not good for you. So once an installation is complete, you must pressurize and pressure test the system for leaks to be sure that all connections are secure. The system must also be inspected to make sure that the work has been done according to the job specifications and application codes. Matter of fact, that should be done before you pressure test the system. So in other words, it should be inspected. In other words, you checking your joints. Matter of fact, every time you make a joint, you need to inspect it. You get a mirror and a flashlight and go around your fitting to inspect it to make sure that is done correctly. Always test to the pressure that is specified in your local applicable codes. In other words, if they say to check it at 100 psi, you could check at 100 psi. Can you go higher than that? Yeah, you certainly can. And a lot of times, the pressurizing system, especially if it's in a building that the inspectors want to know what the pressure was, you would actually date it. You put a tag on it, you date it, and you leave the pressure in it. Allow the inspector, you call for inspection before you can close up the walls. They will come out and take a look at it and see if the pressure dropped from that time. And so you date it, and especially if it's a refrigeration system, I would actually put the outdoor temperature, the building temperature. I would put that on the tag too, because certain gases, pressures can change based on the temperature around it. So again, pressurize it, tag it out, put your name on it, put the date on it, and allow the inspector to come verify it. You can pressure test copper tubing with water or air. You are required to supply all the equipment needed for testing, which include the test plugs, caps, plugs, and a source of compressed air if testing is required. Water testing can be done with test plugs and a hose. To test, close all outlets to the tubing system with the caps and plugs in place, of course. Fill the system with water or air and pressure to look for leaks. Again, my thing is that I always tag it out. Put a tag on it and leave the pressure in if it's going to be inspected. If it's not going to be inspected, you want to do it for your own use. You want to make sure before you start the system up or pressurize it for permanent use that you guarantee there's no leaks. Pressure test for DWV systems. So to water test, you can water test it, but that might be more difficult because the DWV piping is large. It would take an awful lot of water. It's easier to use compressed air. But to water test a DWV system, refer to your local codes for the required pressure and water head. Again, you have to add an awful lot of water to it to be able to do it. Here's the thing, you don't have to cap the very end of it, as long as you didn't complete the final connection. You can add water to it, make sure everything is stubbed out. When I say stubbed out, the piping where your sinks and toilets and things is closed off, is capped off, where no water or pressure can escape. Then you can fill the stack pipe, that the pipe's going outdoors, and you just actually raise it up to a certain height, and you have a pressure gauge at the very bottom of the system, and you record that pressure. The vertical rise in a water tube will give a pressure reading. Believe it or not, you can fill it up and you will be able to read pressure. For every 2¼ feet, just slightly over 2¼ feet, you will actually read 1 pound of pressure. So if you're going up 20 feet up in the air, you can divide 2¼ by that, and you will know what pressure you should be at. And that's how you can pressure test it. And that way, the system don't have to be completely closed off. Then once you finish, then you can tie in all your other fittings and uncap all your ends. So pressure testing a water supply system. So to water test a water supply system, close all the outlets, all the valves, and fill the system with water from the main. Next, you're going to inspect the system for leaks or other problems. Where codes specify water testing at pressures higher than those available from the normal water system, which is around 45 to 55 psi. That is normal for a standard supply water system. But they want you to test it at 100 psi and see, because you will be able to find leaks faster. The higher the pressure, the faster you will be able to find the leaks. So that's about twice as high than the city will supply you. So where the codes specify water testing at pressures higher than those available from the normal water supply, you can use a hydraulic test pump to produce the required pressure. Basically, if you notice, this one here has a gauge on it. You just pump it up, and this is an electric pump that can increase the water pressure for you. To air test a system, the plumber or inspector fills the tubing with compressed air. By using a pressure gauge at the test plug, the plumber or inspector can determine if any pressure is lost somewhere in the tubing. Now here's something that is, keep in mind. You can find a leak faster with compressed air than you can with water, because but you can find it either or. Another useful method of identifying leaks in if it's using air, you just use soap bubbles. Every joint is covered with soap bubbles. You will find a leak instantly. So if there is a leak in the joint, bubbles will form in that point. And here's the great thing about it. You know exactly where the leak is at. That's why I like using air, because you can look for water leaks, which is a telltale sign too. Air, you can use bubbles. All right, here's some terms that we're going to go over. A clevis is a type of strap that is a U-bend. Insulation is a substance that retards the flow of heat. So in other words, slows it down for either gaining into the pipe or leaving the pipe. Head. A head is basically the vertical rise in a column, and which calls a downward pressure. A downward pressure. So again, for every pound of pressure, would give us around 27 inches of vertical rise. 27 inches. In other words, if you push water up, or you have a 27 inches of vertical rise, that will give us 1 pound of pressure. All right, some questions. Hangers are primarily used to support tube, but they can also be used to support blank. Is it pressure checks, channel struts, vibration isolators, or C-clamps? Hangers are primarily used for supporting tube, but can also be used to support vibration isolators. The type of insulating materials that require special training uh, for removal is blank, and there's only one, and that asbestos. Where codes specify water testing at pressures higher than those available from the normal water supply used, must use some type of um, pump to do it. So typically it's a hydraulic test pump.